Obrigado. So, hello everybody. I'm really excited to be here with you guys today. I would be speaking a little Portuguese, but unfortunately I have zero, so hopefully the English will be okay. I'm here actually because someone I consider a friend, William Kennedy, Bill Kennedy of Arden Labs, was working with him in Toronto, and we were talking about going down to GopherCon Brasil and having a great conference, and turns out Bill was not able to get his visa to work out in time, and his talk slot opened up. I got the opportunity, and couldn't be happier to be here in front of you guys today, so there's that. Just a quick show of hands before we get started. Who here has been writing Go for 6 months or less? Just curiosity. Anybody? Yeah, quite a, maybe about 25% of the people. That's pretty good. Okay, and I think we can start. This title, a lot of people had questions about it. What does it mean? Where does it come from? What does that possibly mean? Just to repeat it, scratching an itch is an English idiom that means solving your own specific problem, a problem that's a problem for you. If you think about an itch, feel a little funny, like it's not a problem for anyone else. It's your problem. It's your own unique problem that's only really important to you, but it's still important. And what I'd like to do, it might seem a little strange, but I'd like us all to actually say this right now. I think there's a couple times in the talk where it might come in handy if we could all kind of say this together. Like maybe I'll lift my hand or something like that. You guys could say, "Go scratch that itch." So let's just all say it word for word. Go scratch that itch. Okay, so I said it once. You guys all say it.
Go scratch that itch.
All right, I like that. Okay, so we're ready to get started. Okay, here we go. Working a second ago. There we go. Okay, so when you have an itch to scratch, you might be saying something like, there should be some code that does that. There's no code that you know of that does that, or does that in the way that you want it to happen. And really, what I'm going to talk about today is to convince you to write that code instead of not doing it. So there's a lot of moments in life where you can either do something or you can not do it. And there's going to be people who tell you, oh, that's a waste of time, you shouldn't do that, don't bother, it's already been done before, it's been better than you could do it. And really, I'm just here to give you the other side of that, telling you that you should, I want to be a force here today telling you guys that you should do the things that you want to do. Your problems matter. You all have problems. Everybody's got problems, right? They matter, they're important. You don't hear that a lot, but it's true, and you should be writing the code that solves your own problems. It's a simple message, but as we know in the Go community and the Unix Philosophy community, simple can be hard. All right, so how am I going to talk about this? Well, first I'll talk about the fact that small is different. When you're doing something in the large, it's not the same thing as doing something in the small. It's a qualitatively different thing. Scratching itches, what is that about? Some well-known itches, just sort of reviewing some history and talking about some specific examples, and why Go philosophy and features are well suited to programming in the small. So, this is not going to be a particularly long talk. It's not going to be a particularly deep dive into any particular Go code. What I hope that you guys get out of this is motivation and inspiration to solve those little problems you've wanted to solve and do. Go. All right, so small is different. Just a few little examples. How is small different? Well, if you're talking about classical physics versus quantum physics. You can take the example, classic in quantum physics of Schrodinger's cat, where at the scale of subatomic particles and radioactive decay, you have physical behavior that is not what you would expect operating at the larger classical physics scale. So in the classic Schrodinger's cat thought experiment, you have a situation where, according to the Copenhagen interpretation of quantum physics, the cat is both dead and alive at the same time. That's not at our large scale what we expect in terms of behavior, but at a small scale, that's how things operate. Another example from statistics, students' t-distribution. So in statistics and probability, has anyone heard of the t-distribution before? Yeah, so some people. And it's going to be used when you're dealing with small samples. Behavior at a small scale will have a different shape. The t-distribution will be symmetrical and bell-shaped, but less peaked with fatter tails than a Gaussian normal distribution, right? So lower degrees of freedom are the flatter, less peaked ones, and then as the degrees of freedom approach infinity, you get a more peaked, more Gaussian-looking distribution. The late Stephen Jay Gould wrote an interesting paper in a magazine that he wrote for many years called Natural History, about size and shape. And he was talking about, he was a naturalist and evolutionary theorist. He was talking about the relationship between the size and shape of living things. And he wrote, I'll just quickly read this: "The geometry of space itself is the major reason for correlations between size and shape. Simply by growing larger, an object that keeps the same shape will suffer a continual decrease in relative surface area. The decrease occurs because volume increases as the cube of length, length times length times length, while surface increases only as the square. In other words, volume grows more rapidly than surface." And to continue that, he finished that essay by saying, "I once overheard a children's conversation in a New York playground. Two young girls were discussing the size of dogs. One asked, 'Can a dog be as large as an elephant?' Her friend responded, 'No, because if it was as big as an elephant, it would look like an elephant.' And I wonder if she realized how truly she spoke." The point of that paper saying that the physical shape of animals is intimately linked to its size, and I think we can say the same thing for software. So to sort of be more explicit with my analogy, as you scale up software, the surface area, so for example a public API, can be dragged down by supporting utility functions, tooling, boilerplate code. That could be the volume, the sort of inessential volume of the innards and so on. And the question that you can be asking is, can we keep this small? So in the large and in the small, this is not a new idea or concept. I think anyone who's reviewed computing history a little bit and computer science theory will have encountered many examples of discussion of scale, large and small. A well-known paper is by Deremer and Cron, 1975, Programming in the Large and Programming in the Small. There's a link to the Wikipedia article there. Basically, their vision of in the small program does one thing well. It's often coded by a single developer, and it's complete in itself. So an example could be, any of the classic Unix tools. grep would be one. In the large, industrial teams working on systems projects, months to years of time scale, often broken up into submodules. So you can consider operating system or larger sort of industrial designs in the large space. So we're focused today on in the small stuff. And what do I mean by scratching itches? Well, in the Cathedral and the Bazaar, a classic in the realm of open source, Eric S. Raymond wrote, "Every good work of software starts by scratching a developer's personal itch." That might be hyperbole. You could probably find some examples of good software that wasn't specifically that, but I think the point is that a lot of good software starts that way, and that's what I'm addressing here today. So one very well-known itch that I like to talk about, because in my own, I didn't really do my personal introduction or anything like that. Maybe you read my bio on the website, but I do a fair bit of teaching. I was teaching with Bill Kennedy in Toronto, Go programming, but I'll do teaching on sort of Linux fundamentals as well a fair bit. And what I find interesting is that we're using Unix and C to power our internet today and to power all kinds of industrial appliances and so on, but a lot of people just sort of accept them as they are and don't think about the history or why they're still here 50 plus years later. So the story of Unix is one that I think a lot of people also think they know, but actually don't know. So the story of Unix as sort of the perhaps maybe an average developer not that interested in history might go, well, Unix was developed at Bell Labs in the late 60s, early 70s as a developer's side project, and then they saw the commercial potential and they sold it to, or they licensed it to AT&T, gave it to BSD. But that skips over, from my point of view, the whole origin story, the whole genesis of why Unix came to be in the first place. So Ken Thompson was the initiator of Unix, and he developed a game called Space Travel. You can go and look that up on Wikipedia. There's a little screenshot of it. If anyone's ever played the game Space War, it's of the same era, and it plays, it's very similar. You're sort of in space, you have a spaceship, you have gravity, you have orbits, very similar to Space War, if anyone's ever seen that. And it was developed on a GE 635 system. That was a time-sharing system. Developers were using it for a variety of different tasks. It turns out that they had a system internally where there were actual costs to sort of using it, kind of like we have on the cloud today with Amazon and stuff. There's a cost per batch or whatever. It would be $50, $75 or something like that. And so it was getting expensive for them to play this game, and plus the controls weren't so great, and they wanted to Ken Thompson wanted to move it somewhere else. He wanted to port to a PDP-7, which you have seen there below, to avoid Bell Labs' internal usage fees, but the OS was not very satisfying. I'm going to raise my fist right now. Scratch that itch, right? So, yeah. So I guess to finish that story, what did he come up with? Well, he decided from first principles he was going to develop the operating system super minimalistically. Does anyone know where the actual name Unix comes from? That's one that a lot of people have heard.
From Multics.
From Multics, right? Multics was a mainframe OS that was big and bulky and did a lot and bloated, so Unix was kind of a play on words on that. So scratching a personal itch, develop something, because he wanted to play a game, super minimalistic, classic itch scratching. All right, another one that I like. Some of you may have heard of her. She's more of a contemporary of ours today. Definitely someone who inspires me. Jennifer Dewalt, an art student with no programming experience. I think she was at the University of Chicago, if I'm not mistaken, but I might be mistaken, so I should go on her website and check that out later. And she wanted to learn how to turn her creative ideas into code. Has anyone heard of Jennifer Dewalt before? Show of hands? No? Yeah, one person, great. So there's ... I'm going to raise my fist. Yeah. And so what did she do? She did 180 websites in 180 days, and each day was a small self-contained project, open sourced on GitHub, and she wrote a blog post about it. And if you go to that link that I have here, let me just see if I can open that up. It looks like this. So every day is just some idea she had. Here's Talking Dude. I don't know what that's going to be about. It's small, self-contained, did one thing. And what I really like is her philosophy of that. And then she, became a very well-known kind of developer, has a startup, got a lot of people making her offers. And she sort of, through blog and all that, she articulated her approach. What was her approach? How did she go from no coding whatsoever and just having ideas to becoming a fairly well-known and experienced developer? Well, she articulated it as JFDI, just effing do it. Like, you have a small idea, that's the key. Having a small idea and just figuring out, you've got the internet, what are the steps that I need? Like, I'll go on Stack Overflow, I'll Google a bunch of things that are kind of like what I want, and just like push through as much as I can. And also, doing things in the open on GitHub, I think helped a lot as well. So I think one of the reasons that example speaks to me is because if I think about it, and it might go for many of us here today, because I think a lot of people in the open source community here, in the Go community as well, it's how I got started. I didn't study computer science at school. It's actually a little bit of a funny story. The way I got into computers at all was because my dad, who worked for an insurance company, no, not a computer guy in any way, got a family computer back in the late 80s and decided he wanted to write a little system to run for our family. So in BASIC, he wrote not an operating system, but for us it was like the operating system. It was a windowing system in text mode. So we had all these little text windows that have to answer math questions and crazy riddles. If we wanted to play any games on the system, I'd just figure out how to not answer his math questions and play the games. And playing with computers was fun, but you know, just figuring out, and I have other friends who sort of are not in tech, and they talk to me, and how could I get to do what you do? And the way I describe it, I think it might ring true for many of you as well, is to me tech is like 100,000 rabbit holes. Each individual rabbit hole is not in itself a really complicated thing, like you need to be a genius to be able to do it, but you need to get to know that to get to step B, you need to go to step C, and it's like this, and some of us just get sucked in and we can't resist diving down all those rabbit holes, and that's why I'm here today. All right, last little example, one of my own. I wanted to create something to generate placeholder text. This is a really silly one, but it's just an example of, this was purely my own itch. You guys might find this terribly uninteresting and not your cup of tea at all, but that's kind of the point. Placeholder text, and learn a little bit more about Unicode. So, there we go. I made this tool called Horeb. It's on GitHub. Little command line tool, and the little quotation there, it says, "Speaking in tongues via standard output." It's a CLI tool for generating random sequences of characters from various Unicode blocks. So there's all these Unicode blocks out there. You know, there's math, alphanumeric, geometric shapes, emoji, all these things. And you know, if I want to generate a sequence of those, how do I do it? Well, this tool will do that. It was inspired by another strange tool. If anyone's ever seen Terry Davis's Temple OS, that's, you know, a little bit like what I'm talking about, but to an extreme degree. I'm not seeing a lot of recognition. Terry Davis is a guy who was an engineer for Ticketmaster, I think, in the 90s, developed schizophrenia, moved back in with his parents in Las Vegas, and for 10 years or so, worked on developing, like he was a very skilled engineer though, programmer. For 10 years or so, worked on an operating system that changed names over the years. Now it's called Temple OS. He became a religious, you know, fairly fanatical religious person. So the purpose of the operating system is to praise God, but you sort of go on these journeys out into the desert. It's sort of graphical, you walk through it. He's very active on the internet. He does live screencasts like on a weekly basis on YouTube, walking through his OS. He wrote a dialect of the C language called Red C for it. If anyone's curious, and you know, you can run it on QEMU or whatever if you want to play around with it. Anyway, that's another example for me of you know, one person solving their own problems, but maybe in a bit of an extreme way. All right, so that's that with that one. I guess quick demo of like what that looks like, I suppose. So if I just say I want geometric or dominoes, you know, that'll print that. If I want some more of those, I can do, you know, 2,000 of those, and then I'll get a whole bunch of dominoes and geometric shapes. I can do, you know, list out the ones that I'm doing. Anyway, so a little tool that just solved my own little problem for the moment when I was working. But it's not just me who has problems. Everybody has problems. And the real core message that I'm trying to put forward today is that your problems are important. Your problems, the things you've thought of, things you're saying to yourself, it would be kind of cool if you could do that, or I kind of wish you could do that, or you know, how come there's not something that does that, or there's like 5 things that do that and they all suck, and I wanted to do it this way. You have unique local knowledge, and if anyone is interested in economic theory or other things like that, it's sort of, you know, why entrepreneurship works, because the local knowledge that an entrepreneur has in that local environment, they know that, you know, in this particular city at this particular time, this is in demand, and the other entrepreneurs are not doing it this way, or they can gain a competitive advantage that way. I mean, it kind of works the same way with with software and with ideas in a lot of ways. Like, there's not anyone else with the exact same local knowledge or friends or interests or whatever. You're involved with a X team or a Y group, and they need a piece of software to do Z. Maybe you're the person to write that software. Contrast with centrally planned software or designed by committee. I think, I guess this would be hardware, but I remember reading about Apple and Steve Jobs, talking about how come Apple had been so successful in getting people to appreciate their hardware when other competitors with great resources like Samsung and so on never really had the same kind of hits that Apple had. And the theory of this editorialist that I was reading was that at Apple there could be sort of one man with a vision who was able to get that vision to market, Steve Jobs, right? He was meticulous, he'd have his hand in everything. Whereas at Samsung, the culture at that company was that you'd have to go through about 12 middle managers with your idea, and each one had their comments and this and that, and it was not a straight line. Designed by committee is sort of a concept that's been discussed to death, but it's always worthy of mention, and that's sort of the difference. You will not have designed by committee when you're scratching your own itch. So a few principles for programming in the small. I like the first one. Solve the problem in the concrete first. So to me, Ken Thompson is someone who I find inspiring. I think many of us probably do, as he's one of the co-creators of Go as well. And I'm going to mention the Unix philosophy down there, but I remember reading at one point that someone was interviewing Ken Thompson, and they asked him, okay, all these years later, it was maybe 30 years after Unix, if you had to sum up in a phrase, what is the Unix philosophy, what would you say? And he replied kind of like a Zen master, and he said, when in doubt, use brute force. That is the Unix philosophy. And I think you can interpret that in a few different ways, but solving the problem in the concrete, don't get overly academic about it. You want to get from point A to B. Do what you need to do quickly to get to point B is I think in many ways the philosophy that's gotten Unix and C and now Go as far as they've gotten. Consider existing tools. Reinventing the wheel. You can reinvent the wheel, and I think especially if you're working on your own software, your own problems, maybe you want to not reinvent the wheel, but rediscover or re-implement the wheel for learning purposes. That's a separate issue. But if that's not what you want to do, then if, for example, if you want to write a little tool that does some web scraping or something like that, very simple web scraping. Not you're not dealing with big databases or anything. You're just going to download a bunch of files. Maybe what you need to do is just write the part that scrapes the URLs. There's like 5 or 6 really good tools that do multi-threaded downloading. Do you need to implement that yourself? You can, and it's actually just a few short lines of Go, as we know, but consider whether you do or not. The Unix philosophy. So many of us are probably familiar with what that means. I think there's a formulation that I like by Doug McElroy on the next slide, so I'll come back to that. Yagni, that's another one that kind of goes hand in hand with the Unix philosophy. You ain't gonna need it. We'll come back to that one too. And make your objectives clear. Readme-driven development, I like that one. That's Tom Preston Werner, one of the either the creator or the co-creator of GitHub. I can't remember if he had a co-creator or two. And he's written a little article on that. That's his style of development now, is readme-driven development. If there's anything you can do to really make your vision clear first, write the readme first. Write how you're going to use this tool first. Write it all out really clearly on paper so that it can be discussed and debated and revised, and then start coding. That's, to me, I find that a nice approach. So this is the formulation of the Unix philosophy by Doug McElroy. Write programs that do one thing and do it well, write programs to work together, and write programs to handle text streams, because that is a universal interface. And there's all kinds of formats these days that are moving to binary. You've got HTTP2 that's binary by default, and all these other things. But you know, I think binary protocols and binary streams have their place. But one thing you can say for sure is that as long as humans are using computers, text is going to be understood. We're going to be able to work with text. The binary protocol or binary sort of formatting that you've come up with, are people going to remember how that was written? I mean, it has to be well documented, but text is always going to be simple and easy. All right. Down below you, I don't think you can see it too well, and I think I can't scroll down easily here, but I mentioned Acme. I don't know if any of you are familiar with that. Russ Cox, we all know who Russ Cox is. I came to Go actually a little bit unusually. I came from the Plan 9 community because I was interested in that in the 2000s. Plan 9 was an operating system, for those of you who don't know, that was kind of, okay, Unix has been around for 20 odd years. If we had to rewrite Unix today in 1991 or whatever it was, with what we know now, we've got TCP/IP, we've got mice, we've got all these things, what would we do differently? And so they made something more Unix than Unix. Rob Pike was heavily involved with that, Ken Thompson and a lot of the early Unix guys. And Russ not at the time, but the Plan 9 port, port of the Plan 9 tools to Linux and Unix-like OSs, he was the guy running that for years. He still is, I think, the chief person in charge of that. And the text editor for that is called Acme. And he has a screencast on YouTube, Russ Cox, of an introduction to the Acme editor. And he calls it, and I like the term, an integrating development environment instead of an integrated one, because what it allows you to do, I don't know if I can demo it because I've got it installed. Yeah, this is Acme running on Plan 9 port on Linux. And the one thing that I want to show you is just that any text that you type anywhere in the editor, so if I do any text, you can use the mouse, just click on it and run it, thank you. And then you can work on that text and pass it through pipes and so on. Everything is editable, 10 minutes, that's fine. So it's integrating because it doesn't require you to learn a whole new style of working. You use all the tools you already know with pipes and so on, but use them in an integrated way. Okay. Yagni, I guess this is all I'll say about this. Nice little XKCD comic there. This is what you want to avoid when it's time for you to generalize and abstract away. Do so, but doing that prematurely is a recipe for much more code than you need, not just getting from point A to point B quickly. And when programming in the small, solve it in the concrete first. Don't abstract. There's always a cost to abstraction. If you're sure that you're going to need that abstraction later, then go ahead and write that initial abstraction, but there's always a cost. Go is good for programming this small. It's the last part of my argument. I've got 10 minutes to make it. Okay, so you guys might, I don't know if you all remember the original Go logo with like the moving gopher. I think that's important. The gopher should be moving. Go, it's all about going, moving forward, doing instead of not doing. That's the point of my talk today. I think that I'm going to put that little movement symbol anytime I see the gopher. And yeah, consider the Go name short, simple, moving and doing. The Go spec is short and readable, as opposed to other specs that you might find for other languages that are dense and impenetrable, or that you're only going to understand 5% of because it's just so massive. Go says no. I think that's actually one of my favorite things about the Go language. It sounds funny, but it's probably true. Go says no to ideas that it's not confident in implementing well, or that can be done differently in a simpler way. I put a link to the discussion about generic that Russ sort of thoughtfully was writing about, talk about exceptions in the FAQ. I don't think I'm going to dive deep into too many of these right now because my time is limited. The fact that it's implemented as a procedural language, when many in sort of the academic community were saying, functional languages are the only way forward. I mean, that's the future. We can, we're actually pretty productive in a procedural language. We're doing just fine. So, easy deployment. Simple minimalistic tooling. you know, a lot of the time we can say goodbye to make files, virtual environments, package.json, we don't have any of that. Cross-compilation is trivial. That's pretty great if you're working in cross-compilation environments. Static binary is always nice. So it's not just about deployment, but using. So actually the act of writing your software and then using it, which should be really simple, turns out not to be simple in many languages because all the tooling, incidental complexity that you get with many of the languages, Go just goes from point A to point B. Polymorphism without pain. Interfaces are great. I love interfaces. We all do, I think. Allow reusing code in the OO style, but via composition instead of requiring rigid object hierarchies, abstractions that oftentimes are not thoroughly necessary to get where we need. And I really like a blog post by Rob Napier called Go is a Shop-Built Jig. I'm not going to dive too deep into this. I guess a shop-built jig, it's kind of weird idiomatic English meaning something in a woodworking shop that is a tool that is built by the people who are using it day to day, and it's kind of something that looks really funny and weird, but is perfectly suited and tuned to getting things done in that context, in that woodworking shop. And he argues that the Go is the programming language version of that. I have a couple of other, these slides will be on GitHub eventually, quotes from there, but that's the bottom line there. So key takeaways from this talk. Principles when programming in the small. Solve the problem in the concrete first. Yagni, when in doubt, use brute force. Consider README-driven development or just getting your ideas down on paper before writing any code. Go features that are good for programming in the small. Small spec, says no, easy to deploy, easy to use. Interfaces, polymorphism, code reuse without rigid object hierarchies. Community is vibrant. Third-party libraries are good compared to competing language ecosystems. So that saves us reinventing wheels. Conclusion. Programming in the small is good. Go is good for programming in the small. Your problems matter. That's like the best one, the biggest one. And
Yes. All right. Thank you, everybody.
Congratulations, John. It's an awesome talk. Felipe and I, we created an open source project based on this idea. We had a problem in our company and we started, okay, let's build an open source project, solve our problems and help out the community. That's a good target. Thank you very much. Congratulations. Okay, people are asking for questions. I'm sorry, guys. Any questions? Somebody has some eats? Okay. Thank you very much, John. Agora